Hello, welcome back once again. This is Samuel Ambrose Onen, your tutor. And, we have finished up our course, but I thought it would be nice for us to prove some concepts practically, although it's not going to be like a practical that you see on a computer, but we are going to go through some application of this concept of the model for understanding computational and algorithmic problems. This model there, the giant model that you see on the screen, nu equals to b times a transformed. So I am going to go through this model, which is going to summarize everything that we have learned from this course. But the main focus for this course is going to be on three things. I would say four, and that is the knowledge base, you know, and we are going to focus our attention on the initialization or the instantiation of the problem, where the problem comes from, where the problem starts from, and we are also going to see how the problem scale up with time in the space. So we are going to model the problems as being vectors in the space because problem must start from a point and problem must end at a point. So that is all about it. It's all about the course, but let me put it into perspective by bringing to your attention some of the things that we are going to learn. And that, my friend, is going to be about the application of this knowledge in real life. So, based on that, let's get started. Well, from the previous video, I gave you some kind of demonstration, but it was just on paper because I just wanted to show you how I built up this model. But now we are going to put that into practice by looking at the example of how the system is developed and how it works. So let us take this as an example which can be applicable in real life. You can put into practice and actually, you know, do it realistically on a computer to implement it. But I'm not going to use computer system to implement this. I'm going to explain everything here, right here, for you to have the mental understanding of it before diving into the computer to start coding. Now, in real life, the problem that I demonstrated before, um, the problem that I showed you before, let me show you. In real life, the problem I demonstrated before to be the A, the A, and the B was the expected solution. A was a problem that I modeled to begin from some point in the space, and if problem exists, then it must terminate somewhere in finite time. That's where we can get the solution. So the problem will be like a vector moving on the space with some quantity. So we need to find the solution by applying the functions on this thing until when we get rid of the problem. So this A is modeled as the problem and mu as the solution. So the problem will escalate from A so that by the time we get the solution to it, it must reach to this point here. So my friend, the solution will be the linear combination of A times mu, which will be equal to the expected solution B. This is what, in software development, this is what the stakeholder will come out with. It's like they will expect us to do something. And that something is what they want to do in order for them to make money. So the reason for doing what is for them to make money. And they know what to do. They know what to do. They know what problem exactly they want to solve. But what they don't know is how to solve it, how to solve this problem, how to solve that problem. And that, my friend, is where we come in as software engineers to provide the solution, the absolute solution, which is the transformation of the problem completely, but it must be commensurate with the expected output. So if the problem, if the solution does not meet the requirement, the software will be rendered useless. But if the solution meet the requirement, then we are good to go. We have got the solution for the stakeholder to make their money. So this is basically about my model. And now we are going to apply it in real life. So the stakeholders has to come up with the requirements. And for us, we have to break the requirement down because those are the problems and then apply some function to solve it for them. So knowledge is very important in this case. That's why we do requirement engineering, we do feasibility study, we do a lot of things to study about the problem before actually taking over the software development. And then this knowledge is also very important about why the stakeholder wants to solve the problems. Maybe they saw that the system does not exist in the market. So by bringing a new system, they will make some money. Yeah, they have to come with something which is um, something which is new. That's when they will make money before anything else come to to destroy them. So we need to provide them with the solution. So the knowledge is very important, and that is the key in software development, in computer system, in artificial intelligence, in anything. Knowledge base is the key in everything. Even in our life, you cannot survive without knowledge. If you don't know yourself or you don't know nothing about you or about anything, that means you don't exist. So the type of knowledge that we need here to tell us how is called the imperative knowledge. Imperative. Uh, Imperative knowledge. This is the knowledge that will provide us the solution. But we have the what, which is about the uh, declarative, declarative knowledge, which is about what to do. And then we have this, which is comparative, comparative knowledge, which about how, what, why, where, which. So all this knowledge are embedded inside how, imperative, which is about the solution that we want to find to get the problem. So we'll use all this knowledge to come up with a function that will solve this problem. For example, the what knowledge, maybe we can use it to declare variables or declare class or solution. Some functions. And the why, which, where, when, we may use it for the control flow in the system to apply some logic so that we can be able to solve this problem. So that's just a brief demonstration of what we expect to do on this. That's why the organization requirement could be the problem definition, as we have said. This is what we want to do. So the organization can say, we have a problem of changing the background color of our system. We want a system that can change red color to yellow whenever the current color is red. For example, they have maybe some presentation screen, so they want to press some button, and then that button could be like a change button, just to change the color, to switch between the color from red to yellow. Sometimes we can come with a function that will do the reverse as well. Red, yellow, yellow, red. Or maybe the function could be for the traffic light, for crossing the road and things like that. But This overall thing is a statement from the organization. And this statement, my friend, is what is called the business the business use case, the business objective. They want the light to change from red to yellow so that they do something, maybe so that they give warning for people to now start crossing or know that, well, red is danger, yellow is amber. So they want to achieve that, So this is a complex problem. Uh, it's a general requirement. It's a general requirement. So, what do you do as a software engineer when an organization has given you something like this? Where are you going to start from? You may say, "What? How am I going to start developing this system?" This is where many people get it wrong because some organization will get a programmer and then they start writing codes. Boom, 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 boom. Let us get red to yellow, without following the right principle and practice of software engineering disciplines. So that is going to be another course about software engineering principle and application. It's going to be my next course actually after finishing this one. Remember, this course comprises of 5 different modules, for you to become a fully blown algorithm, somebody who can design algorithm properly, because we are going to implement it with Java. And that is what I'm going to use for proving this concept now to get in this example. So this is a general requirement. You don't just need to dive in the computer and start writing codes. You have to get the specific requirements from this general requirement. So that's going to be our next topic in the next video. So thank you for viewing. I'll see you in the next video. My name is once again Samuel Ambrose Onen. I PhD and MSc holder of Advanced Computer Science, and I'm a reader of mathematics and computer science from one of the outstanding universities in the world. Thank you.